welcome you to the Data Visualization Work Group. We are sponsored by the Pacific Northwest Aquatic Monitoring Partnership. We call it PNAMP, and we're also sponsored by the USGS. I'm Sharon. The group is also sponsored by Denise Kelsey and Keith Dublonica. Our goals are to explore the best practices for visualizing natural resources data, and also to find how to best make data at multiple scales, easily accessible for multiple audiences, and to learn from each other. We sponsor presentations from our members and from others throughout the United States who are developing visualizations for natural resources data. There are links to find out more information about our group, sponsored by PNAMP, and we have a project page. If you go to the pnamp.org, here is our project page, Data Visualization, and we have a lot more information there, including a resources document, which everybody's welcome to contribute to, right here. And I would also like to point out that there is a community for data integration sponsored by the USGS. Anybody can join, and there are a lot of collaboration areas at the CDI. And the reason I thought about them now is because their last meeting last Wednesday, they focused on data visualization, and Ben Letcher was one of the presenters. Then I corralled him to give us a presentation today. So thank you, Ben. Here is the community for data integration. There is a website where those meetings are recorded. You can see them after they have taken place, and a reminder that we have a Google Drive folder too. I actually would like Neil to present first. Part of the reason for that is that Neil is in the region. Neil.ward of QW Consultants. A little over a year ago, in June of 2018, Nancy Leonard presented story map for Fish and Wildlife from the Northwest Power and Conservation Council. And what Neil's presenting today is an update on that, but also there are new tools for the Northwest Power and Conservation Council.
Okay, thanks, Sharon. Appreciate this opportunity to get you guys up to speed on what's been developed for the council since the last time you saw a presentation. As Sharon said, Nancy gave you guys an update back in June of last year regarding what had been developed at that time from a data visualization standpoint for the programs that council implements or has implemented through them. This screenshot right here, for those of you that actually participated a year ago, what Nancy did was she provided some tours of some Esri story maps that had been developed for them. Story maps included artificial reduction, fish screens, as you see, fish objectives, a toxics contaminants map, as well as their lands program. The other thing at that time that had been developed were story maps for individual projects that are funded by Bonneville through the Council's Fish and Wildlife program. And as Aaron alluded to, since then, we've been working with Nancy, the rest of the council staff, as well as many folks in the region to further develop this data visualization tool. And that's what we're going to do today, show you what over the course of last year has been done and what's now actually available. It was just released. This website, data visualization tool, was just released last week. But before we go into the tour, we thought it'd be good to give you a general overview of how we got to the final product. It wasn't easy. And in doing so, but to ensure that we're delivering a product that was going to be useful to a broad audience, we made sure that we had multiple phases in the development that ensured we were including the users, the potential users. We wanted folks to essentially have some ownership in the final product beyond just the council. So what Nancy implemented was basically a 4-phase process, with that first phase being an effort that was internal. She surveyed council staff, her colleagues. She surveyed the council members as to what types of information would be useful, and then more importantly, how that information should be displayed. In what manner are they going to be able to best understand it? But more importantly, for council members potentially, how would they be able to take those documents, those visuals, out into the field to try to inform their constituents? The next phase was we took what we heard from those folks, we developed a prototype, and then tested it with a focus group. That focus group represented a broad group of potential users, including the general public. That was one thing that we knew was important because this was going to be a public website. We want to be able to inform the public in a manner that's successful, in a manner that when they come to the website and they're looking at these visuals, we catch their attention and we keep them on the site. They don't leave immediately to find the next best place, or they start, say, trying to plan their next vacation. Following that particular phase, that focus group, Nancy then met with the Fish and Wildlife managers individually. She vetted what had been developed at that point with managers. She met with 31 Fish and Wildlife managers from throughout the Columbia River Basin, representing 15 states and tribes. Based on the input she got from those groups, those individuals, we were able to develop the final product, which we'll be touring here soon. But the one thing that was important was, that came out of all these different phases, was we needed, you hear people say sound bites. I'm starting to use the word data bites. We knew we needed data bites that were high level, easy to understand. You know, in the past, people used to talk about the old elevator test. Can you get your message across from floor 1 to 2 or 3? I'm actually going more to the billboard approach on the interstate or the freeway, where you're driving, say, 75 miles an hour, and you go by a billboard. Did that message stick as you're going 75 miles an hour? Because I can't slam on the brakes and go back. Whereas when you get off an elevator, you can still hound a person as you're walking down the hall. You know, keeping that in mind, we thinking of our visuals as billboards, and something that would be limited in text, bright, I hate to use the word flashy, but flashy, have images that are lasting, and also the numbers that you remember after looking at it. So this is an example, you know, that was developed that's associated with the LANDS program. Another example here of, you know, these big numbers, catch your eye, a pinniped, a sea lion eating a fish. Another thing that's included in this are the story maps that look at specific projects, efforts throughout the basin. And with that, let's go and do a tour of what was just released. So again, here you see those various story maps. Let's take a look at one real quick, just to give you an idea of, essentially we're revisiting what Nancy presented a year ago. And this is the LANDS program. Again, that's funded by Bonneville through the council's program. We'll do a tour of the program Performance and Progress, which was just released. But I thought what we could do is take this quick tour through what Nancy presented a year ago, just to remind folks of the many types of infographics that are now available on the council site. And this is the example of the LANDS. This again is using the Esri product, the story maps. With this particular approach, it allows for us to, let's look at the state of Idaho and what they have done in the Pend Oreille. So we can get various information with the pop-ups. For those of you that are familiar with these Esri products, nothing special was done here, no special coding. This is just basic over-the-counter type product. And that was done for a specific reason, because we wanted to be able to hand this off to council and for them to be able to manage it in a manner that didn't require them to have to tap their IT folks. And then what this does is you can zoom in to where the parcels have been bought over the years. This tool is important, you know, in many ways. We've often heard from the science review groups that want to see, well, how is a particular parcel that's being proposed for purchase match up with those that have already been purchased? So with this tool now available to the council, they can work with, say, the independent science reviewers and others to show, yeah, that particular proposed land's going to fill in a gap here or over here, and folks get a much better idea. In the past, we didn't have tools like this that would allow for such a quick answer. Folks would often have to visit multiple sites. So now at least we have the, and I hate to use this term, but I'll use it, the one-stop location to answer many questions that we've often heard through the years. Okay, let's try to get back to so now hopefully you're seeing a page that says Program Performance and Progress. This is the tool that was just released last week. Again, it was the result of this past year's worth of effort that went through that 4-phase process. And what we'll do, I'm gonna walk us through, well, we'll try to walk through most. I'm gonna kind of fly through these, you know, big colorful pictures, big messages. We're not asking a user to have to read a lot and remember a lot. What we're hoping that they remember are key items, key numbers. For example, this, you know, the number of days that it takes for a juvenile salmon to swim downstream or move downstream from Lower Grant to McNary. It's been reduced by 10 days. Something else that I want to touch on here, I didn't mention this earlier. When this was being developed, we worked very, very closely with the council's public affairs staff. You'll notice in the lower left-hand corner, the icon that says share. This is going to allow, with that share button, it's going to allow public affairs and others, you know, internally to use these products for their social media feeds. One of the ideas going into this, and now actually coming out of it, was we want to be able to make these products readily available for, say, their Facebook posts or Instagram, something like that. We know those routes now are just another way to promote your efforts, and I think it's a great coupling of you know, these high-level messages being put into those social feeds. So we'll continue on. Just another example of, you know, this is what has been accomplished through the program since 2008. You know, many sites have been addressed, and many acres and miles of stream and habitat have been improved. Slide that you've already seen. One that really addresses hatcheries, number of fish that were released a particular year, number of predators that have been removed in the basin through the program. Just a general schematic of returns of fish. It's not a scatter plot. It's not a box and whisker. It's nothing super statistically scientific. That would have been overkill for our known audience. And then at the bottom of this, it gives you this particular section, you know, access to stories, handouts. Again, handouts that are high level, numbers. Again, these handouts were actually developed working closely with council staff and members with the idea that they could be used by council members when they actually go out and talk to constituents. This is one of those examples of how they can better inform constituents when they're out in the field talking with a rancher or someone in, you know, the fishing industry. Let's visit the next section. My basin. And what you're going to see, that general theme here, as I said, the approach we use with this data visualization is just big numbers, a lot of color, some movement. You know, these numbers represent, in some cases, they may be the past year. In some cases, they may be a 10-year period. You know, we try to remain consistent on a general section as to whether it was a 10-year period or individual year. And I'm just going to kind of move through this quickly because, again, it's that same general theme, the big numbers, limited text, but text that, I mean, it conveys the message. And the thing with these types of high levels, this is just a roll-up of that fish screen story map that's available also on the site. This is a unique section. This is a little different than the others. This is essentially a dashboard, and we're going to be looking at a more elaborate dashboard in a little while, but essentially a dashboard for each of the regions. For the Fish and Wildlife Program, Columbia River Basin's broken into different regions. You know, for each region, the numbers change, and it gives you acres of habitat improved during a certain time period, amount of money invested, and we can continue to look at each of the different areas and quickly access those types of data points that often are important to, say, decision makers when they're talking with constituents or the public. And there are, these handouts that were developed. We could take a look at this one a little bit closer. Again, this is what I was referencing. I said the council members could go out and talk to constituents. They could carry this in their back pocket, and instead of trying to recite something that's long and wordy, they could just put this right in front of folks, and there are the big numbers. Hot topics. And again, you've seen that particular one. Invasive species, as is the case everywhere in the country, is a big issue here in the basin. This particular visual is about zebra mussels, number of stations we have in the basin, and the number of watercrafts that were intercepted that actually were contaminated. Some success stories regarding certain species. It's pretty cool. Oregon chub were removed from the endangered species list in 2015. Sockeye been reached in the Yakima first time in over 100 years. And actually, the kokanee fishery at Ponderay was open after a pretty long closure. For anglers, that's a long time. Another example of work that actually was done in Montana, went from a Superfund site to a state park. Some things that are really of interest, concern to us here in the basin as well as everyone else is, what is happening to our resources, what's going to be the vulnerability due to climate change. So, again, these are super high-level messages. What we want folks to do is, what they see here, we want them to become more interested. They can dive into the information that is actually going to be coming here in 2020. When the program tracker becomes available just around the corner, folks are actually going to be able to learn a whole lot more about what's being displayed here. Basically, it's the behind-the-scenes information. And with that tracker, they are going to be able to get into the proverbial weeds if they are interested in doing so. The whole idea here was we essentially wanted to wet their whistle. We wanted them to become informed about the program and actually so much interested that they will go in and use this tracker. And then one last thing that I'd like to show you that's being developed right now, hopefully it's going to be released in the near future, potentially next month or in the start of the new year, is a tool for the northern pike issue that we have here in the basin. The council's working with the Washington Species of Invasive, Washington Invasive Species Council to build an online educational tool to inform folks about the northern pike issue. Right now, northern pike are 57 miles from salmon habitat. They're just above Grand Coulee. Once they get below Chief Joseph, they're now in salmon habitat, salmon country. So this particular tool, again, this is part of the ESRI package. This is an operational dashboard. These types of dashboards you often see cities using, police departments, fire departments, they use them for risk management. So this actually fits really well because if you think about this scenario right now, Northern Pike, it's a risk management, risk scenario. This particular window we're looking at right here is a high-level visual for the situation. We can see that in 2018, 3,300 fish were removed. Those are fish that have been removed through multiple programs, multiple funding sources. We've been fortunate enough to be able to cobble together all that data to make it available in this particular illustration. The amount of money spent is actually in excess of $1 million. This particular illustration shows the downstream expansion in the past year. And then we're able to illustrate also the number of fish removed annually. So if folks want to actually, so that's a great message, that high-level message for the public. It does demonstrate or create that sense of alarm. These fish are moving quite rapidly. The fact that it is pretty spendy to try to control them. But what's really important is what's going on at each of the other reservoirs. And that's where we actually start to dive into the proverbial weeds. Because this particular tool, again, is being built for a very broad audience. We want it to be educational for the general public, but we also have heard from the science community, especially those reviewing these efforts, that there needs to be a way to track our progress for controlling the fish. And with this particular section of the dashboard, we can dive into each of the, or we're taking the viewer into each of the reservoirs to see how successful the managers are or have been at controlling the fish. In this particular example of Box Canyon, it's been a great story, how successful they've been from 2000 to current, removing fish and essentially controlling that population. So yeah, it's in this particular tool, because of the way it's built, it allows for it to be easily updated annually. And we're working with the managers to ensure that that data are available annually so that this doesn't become essentially outdated. Because with this particular issue, the last thing we can afford is for a tool like this to become outdated, given what's at stake here with the Anadromous fish just downstream. So Sharon, with that, I'm finished with my presentation. There's a lot to look forward to coming from the council regarding data visualization and some new products that, to the best of our knowledge, these types of dashboards aren't being used as often as they probably should be here in the basin. The Yakima Nation actually has two right now. They have one for fish counts on the Yakima River, and they actually have one for habitat improvements in the mid-sea that's been developed. And they're going to start to expand that type of approach, or approach for demonstrating their habitat improvement beyond just the Met, Howard, Wenatchee, but into some of the other subbasins also. But I think there's going to be some really exciting opportunities here in the future for, say, council to come back to you guys and give you some additional updates on how things are progressing with their data visualization efforts.
Right. Thank you, Neil. We have a question for you from the chat. And Lisa asks, what program drives the dashboard? Is it Esri?
Yes, it is Esri. So it's really cool. The Esri product, dashboards are essentially part of the suite. And with these dashboards, 1, 2, 3, I don't know how familiar you are with Esri, but 1, 2, 3 is, again, another component of the suite. These can be real time. If your managers are out in the field, say, collecting data, it can feed these dashboards, and you as, say, if you're upper level management, you could be sitting at your desk while the staff's in the field collecting data, feeding this dashboard, watching this dashboard move accordingly.
Right. We've had a couple of presentations about that. I think Dustin Welty might be on the call. He talked about using collector, survey 1, 2, 3, and there's collector that interface with ArcGIS Online. And
correct.
So, right.
There's also a new app out there called Quick Capture that can do that as well now.
Oh, cool.
Well, I think we'll go right to Ben. We'll have some opportunity to ask more questions. Now I'd like to introduce Ben Letcher. He's a research ecologist at the USGS Conte Anadromous Fish Lab, and he's from the University of Massachusetts at Amherst as well. What I saw Ben present for the CDI was the Interactive Catchment Explorer, but as I started looking at the Spatial Hydro-Ecological Decision System, SHED, there are a lot more pieces, parts to it. So Ben, I hope you'll show us a lot more of the SHED system, and that's ecosheds.org. Thank you, Ben, and take it away.
Thanks a ton for the opportunity to tell you guys about some of the stuff we've been doing for the last 10 years. I'm an aquatic ecologist and an ecological modeler, but I was having trouble communicating and understanding some of these crazy complicated models that we've been working on, mostly based on pit tag data for quite a while. So I got into this world of data visualization over the last 5 years, more or less, and it's been really, really fun to create tools that help us explain these complicated models and help us understand the complicated models as well. But it's been really satisfying being able to share some of these visualization tools with people that need to understand the models, particularly natural resource managers. So a lot of what I'm going to show is targeted towards natural resource managers, but there's also some that are have been targeted towards the general public, more like Neil was showing. So I'm going off the premise that we as researchers in particular do science to inform management, especially at USGS. And my confession is, as you could tell, since I told you that I'm an ecological modeler for the most part, is that I really love the details, and I can get lost in details like you wouldn't believe. I love the trees. Sometimes I lose the forest, but of course, the details don't usually help managers make decisions. So, like I mentioned, in the last 5 years or so, I've been really working hard to try to develop this system to help improve decisions. That's the ultimate goal. Really, that's what we need to be able to assess, is how our science and our data, our science delivery and our science communication can help improve decisions and make it easier for the people that are making these hard decisions. And our niche as researchers in particular, I think there's a bunch of us out there now that are good at understanding data and models and more data visualization. So there's this really interesting niche of people, or this group of people, and this growing group of people that understand all of these things and are able to bring them together to help improve decisions. And I'm really excited to see what you guys are working on. I didn't know about your group before, but I think this is awesome that you have a group focused around data visualization and communicating science. So as we all know, effective visualizations can help deliver and explore and understand science. And the goal is to make communication of these complicated models and data easier and faster. And a couple of things we've learned in particular from doing this over the last few years is thinking about the visualization from the start can really help focus project planning and implementation. So often it's something that people tack on the end, the data visualizations are. But I've found especially with new projects and group projects, is laying out what the visualization looks like and what you want to accomplish with it can really benefit the whole project, not just at the end. So that's something I'd recommend people can incorporate potentially into their projects. The thing we're really bad at, I talked about the niche that we're good at, is that we don't really know how to evaluate visualization use. So we really need help from, I'm not even sure exactly who, but I know businesses definitely do this. We need to understand better how to understand how the visualization actually affects decisions and how people are using it. So I think that's a place where we're lacking right now and could use a bunch of help. So we've for all the visualizations that we've developed, and I'll show a few of those in a bit, we've kind of adopted this visual information seeking mantra that Schneiderman way back in '96 thought was really important. It was so important. This is actually a little clip out of his paper. He repeated it 10 times in the paper. Overview first, zoom and filter, then details on demand. So a lot like Neil was showing. He was showing the overview first, and then there's some ability to zoom and filter. And the reason we want to think about sort of this progression of things is that we have to avoid cognitive overload and having people just trying to understand visualizations that are too complicated. Again, a lot of us love the details and we want to put every little detail in there, but that's just not an effective way to communicate science. So we want to follow this overview first, zoom and filter, and then details on demand kind of approach. And we've tried to adopt that in most of the visualizations that I'll show you. I'm a pretty good programmer, but Jeff Walker, who's a consultant, is a really good programmer, and he's a really person who understands how visualization can communicate science. He actually has a PhD in hydrology from Tufts University in Boston, and during his PhD, he was working on complicated models and having trouble explaining them. So he spent a bunch of his PhD learning how to use D3 and other tools to help explain these hydrologic models. Luckily, he's interested in fish and landscape kinds of things that we're interested in. So he's worked with us over the last 5 years to create a bunch of these visualizations. I've written some of them. I love programming and making these things, but Jeff is the real expert in this. So what I'm going to show you, everything we've done is we've tried to use open source, and it's all available online. If you go to ecosheds.org, you could follow along or play around with some of these things as I show them to you. And I'm happy to talk more about this, any of these, what it took to make some of them, or any advice. I'm happy to provide that afterwards. So EcoSheds, I'll show you in a minute, but the ones I'm going to hope to get through, I don't know if I'll have enough time to get through all 5 of these, but most of them have in common that they use cross filters. So I wanted to focus on cross filters because they're a really powerful tool for exploring data and for having data interact with maps, as you'll see. So I'll start out with some PID tag visualizations that we did to help us understand our PID tag data, and then a fun new one that's in beta that's not part of EcoSheds yet, a tagged animal movement explorer, and then the one Sharon mentioned in the beginning, the interactive Catchment explorer, and then maybe a couple others if there's time. Okay, so this idea of a cross filter is what it lets you do is explore multi-dimensional data really quickly. And if you haven't seen them, it's really worth taking a look at them. You can incorporate cross filters into your web apps using NPM. You can go to this site, or if you just want to understand cross filters, there's a ton of demos and tutorials if you search for cross filter and JavaScript together. What they are one person calls them coordinated visualizations, and the interesting thing there, so what they're talking about is coordinating the how you're exploring the variables. So if you have, as I'll show you in a minute, a bunch of histograms, they're all linked together. So when you change one, the filtering basically works across all the histograms. So what this lets you do is link histograms to each other, or possibly link histograms or data to points on a map or somewhere else, or shapes on a map. So this is my big plug for cross filters. We really like them and have gotten really far, I think, with them in incorporating them into maps and other things. Okay, so I'm going to try to do some live demos here, and again, so most of what I'm going to show you is in this Sheds ecosystem, and you can find that at ecosheds.org. We're slowly migrating it over to USGS cloud Amazon services, but that's not as easy as we hoped. So for now, it's still at this ecosheds.org site. And Sheds stands for Spatial Hydro-Ecological Decision System, and really the idea is to link data sets and models and decision tools together with data visualization, helping explain these things and giving people access to the data sets and the models. So I won't go into a ton of detail about all these, but I'll show you a few of them. A lot like Norwest, we developed a stream temperature database that is pretty easy to use, and we don't actually have to do too much to it. Jeff built this in such a nice way that the only thing he has to deal with really is user accounts. So whenever anybody needs a new user account, that's the step he's involved with. It's really easy to upload data to, and to actually, a lot of the states we're getting tired of having data requests, so they're happy to have their data in there so that they can accommodate data requests for stream temperature. A lot of our models are catchment based, or watershed size is a driver in the model. And unfortunately, when we started this about 5 years ago or so, NHD plus wasn't consistent across the range that we're looking at, which is, as you can see here, from Virginia up to Maine. So we developed our sort of interim version of a high resolution catchment delineation that we use to drive a lot of the spatial stuff you'll see in maps, and in those small watersheds go into the models as well. And the models we have in particular are a stream temperature model, and we actually here in the Northeast like brook trouts, and people want to conserve brook trout. So there's a Northeast brook trout occupancy model. They're used as kind of a canary in the coal mine, or as an indicator of cold water. So a lot of states are interested in identifying brook trout habitat use as an indication of potential climate refuges going into the future. So a lot of what we do here is to try to help people, managers in particular, identify those refuges. And then there's some data visualization and decision tools. So I'll show you ICE. I'll show you a little bit of the data visualizations, some Eastern Brook Trout joint venture stuff, and then the project team. Okay, so first we'll start out with the fish tagging data visualizations, which is this part. You can go to it by linking here. And there's sort of 3 approaches to this. just wanted to let people know what we think a tagging study is, give them a little information about two of the study areas we've looked on. And these are very, very small compared to what happens on the Columbia River and other places in the Northwest. These are third order streams, but if you just mouse over this, you can kind of get an idea of what the stream looks like. This one's in Massachusetts. This one's up in Acadia National Park, a beautiful place up in Maine, right on the coast where there's sea-run brook trout, which is a really interesting thing. Most people don't think about brook trout being sea-run, but they have access to the estuary down here, and they actually use it a little bit, not as much as salmon do. So we have sort of three data visualization stories. Here, one's an overview, and this is more of a narrative, gives a very high level, like Neil was talking about, overview. And then there's the interactive cross-filter. So I'll show you that one. If you want to watch dots move around and see how fish actually use the space in more detail, you could look at the fish movements, but I won't show that one today. So the fish capture cross-filter is this, and most of these visualizations start with a little introduction. I won't go through this, but it just gives you kind of it walks you through what's in each part of the visualization. And so this is essentially like a raw cross-filter, what it would look like when it's actually used in kind of a simple way. So imagine you have a data set that has a whole bunch of rows, and the rows are observations of individual fish. They don't have to be individual fish in this case, but in this case they are. This is from our pit tag study. You don't actually need the individual IDs, so you could do this with any fish data set, or literally any kind of data set, where you have rows that are the individual observations, and then the columns are the variables. So for each column, we have a histogram, and some of these are categorical, like species, or river branch, or season, and some are continuous, like fish length. So the cool thing about the cross filter is what it does is it links all these histograms together. So whenever you filter any one of them, all of the other histograms respond. So right now we have everything selected. Say we cared just about Atlantic salmon, and we wanted to learn, look at the data, all the data for just Atlantic salmon. So all you have to do is click on this. And so now all the other histograms are just data for Atlantic salmon. So you can see really quickly that they're basically only in the main stem. We catch them all 4 seasons. We don't catch them after 2008, and that's because we stopped stocking them when there was a restoration program here in the Connecticut River in New England that stopped right around that, a little after then. And then this is also linked to a map down here where you can see the locations, the size of the circles, the number of individuals, and you can see they're almost exclusive, salmon are almost exclusively in the main stem with maybe a couple of individuals up here. And again, you can see we stopped in 2008. So you can learn a lot really quickly by looking at this. Let's compare that to brook trout. So you can see there, brook trout are in all 4 branches. They weren't tagged until 2002. This started as a salmon study, and then we said, hey, there's brook trout and actually brown trout in here as well. Let's tag them also. And they've turned out to be really, really interesting because the brook trout use these tributaries in very interesting ways. Almost as they pretend to be little salmon. They try to go up here into these tiny, tiny tributaries that you can step across to spawn. But you can see, you can learn really quickly when and where the fish are. Another cool thing you can do is with any of these histograms, you can draw a window over them. So let's say we wanted to know where the big fish are. And let's just focus on the main stem for now. So now we're looking at brook trout in the main stem. Basically, we've unselected all these other ones. So if we draw over this, we can filter now for brook trout in the main stem that are between 155 and 266 millimeters. And you can see there's pockets here where there's lots of fish. And since we know the stream, basically these are where the pools are. And so you can really quickly kind of validate your understanding. The really nice thing of habitat fish size interactions. So you can also drag these along and they interact really quickly. So if you kind of want to make yourself a little bit of a movie of where the big fish are and where the little fish are, you can do that really quickly. You can see it's very rapid interactivity, and that's really important for these visualizations. So this is just a really quick overview of a very simple version of a cross filter, but super handy, a really nice way to introduce people to a data set. And for new colleagues or new grad students, this is a really nice way for them to understand really quickly and on their own what the data set looks like. And again, this can be for any kind of data set, just rows and columns that can be used in these cross filters. Basically, the histograms are just counting the number of rows that fit any one of these bins, whether it's continuous like fish length or categorical like species. So that's sort of the simplest version. Now here's a slightly more complicated version. This is a really fun, brand new project. This isn't in EcoSheds yet. You can see it's in our EcoSheds dev for development site. And this is called TAME, which is, I'm not totally loving this name, but it sort of works. It's Tagged Animal Movement Explorer. And the idea here is eventually, is that anybody would be able to upload their tagging data into this. I know a lot of people get frustrated using programs, sometimes like Esri, to try to understand or to try to map and make movies of tagged individuals. We're trying to make that easy for people. There's a bunch of people that reached out to us to try to help them do that. So this is our development version, and this is an ongoing study in Massachusetts with Trout Unlimited. They're very interested in how water releases from this reservoir and a dam, up this dam. They do timed releases. This is a pump storage facility, so in the evening, often they'll let water go. This is also a destination for rafting. And it's also a fly fishing destination as much as it can be in New England. People come from pretty far to this little location. So there's a lot of competing interests, and Trout Unlimited is interested in understanding how this hydropeaking influences what the brown trout in particular are doing here. So what we're looking at are locations of individually tagged brown trout in this river system. And this was updated a few days ago. And it's really been helpful for TU, to raise money and to raise awareness and to have sort of this real-time, almost real-time, we have to upload the data by hand, but almost real-time tool to be able to look at where the fish are. So I won't show too much detail about this, except that there's a cross filter in here, and you can add any cross filter. Or cross filter for any of the type of data, and the data included here are velocity of the fish, tagging site, fork length, and some other things. But for right now, I'll just focus here on date. So this is a cross filter just like we saw in the previous example, and the idea here was to be able to let people essentially make a movie over time of what individual fish are doing. So it's a little tough to see here because there's a lot of fish or a lot of observations in here, but let's focus just, for example, on this fish. So when we click on this fish, we've selected that individual fish, and if you mouse over, you can get some data about it. But the interesting thing for the cross filter is that we can draw a window here, and you see the orange path that it took, and then as we slide this along, the dots are going to show up over time. So you can make yourself a movie for where the fish was. So most recently it was caught on that little, where you see the blue dots, and it made an excursion. So this fish actually has moved around a fair amount. So the idea is to make it really easy for people to interact with their tagging data. And we have the beta examples we're working with include horseshoe crabs and bears and whales, and salamanders, and a few other things. So hopefully within the next year, this will be up and available for people to upload data into. But it's I think a pretty nice and simple use of the cross filter to be able to make a movie like this. And this was funded by the Community for Data Integration that Sharon mentioned in the beginning. So thanks to them. All right, now we're going to go to the interactive Catchment Explorer, which there's a lot here, and I'm just going to kind of scratch the surface. But the idea is to let people explore spatial data, again, using these cross filters and some other things. And the two major capabilities of this tool are aggregation, so being able to aggregate up spatial scales going from very small to very large. That's often important for people. And then also this filtering, like you can see happening here in this little GIF. I'll show you kind of a live version of that. So aggregation and filtering are the two capabilities. And what most people have used this for is identifying locations that meet a set of criteria. So for example, where the high altitude, cold, low probability of occupancy locations or something like that. And these cross filters, because they essentially operate as and queries, so show me this and this and this, are really easy. When you make them interact with a map like this, are a really nice way to let people identify locations that meet sets of criteria. So the main version of ICE is for this study area from Virginia to Maine, but we've created alternate versions over the years for other places, people that have been interested, for the Crown of the Continent, in Montana and Alberta. And we made one for Champ out by you guys, for Columbia River Habitat Monitoring Program, and a couple others. So it's, most of what we are building now is built using the platform called Vue, V-U-E, and I can show a slide at the end with a link to that, or you can just look it up. It's a really nice way to build websites, and you can make things, you can add components. So basically a map component of this component. So we have that ICE is in that now. So it's easier than before to make new versions. So if this is something that seems interesting, certainly happy to talk about the possibility of doing something like that. Okay, so this is what the sort of main version looks like. There's different levels of resolution from 6 to 8 down to 12, and you can go either finer, as I'll show you in a minute. And then there's a bunch of variables. So what we're looking at right now is for each of these Huck 8s is the average elevation. So there's a bunch of little tiny catchments within this, and among those catchments, the average elevation, for example, for this one is 268 meters, and there's a scale over here. So you can see Shenandoah National Park down here in Virginia has most of the high areas, but there's a bunch of other variables that you can look at, including agriculture cover or let's say current brook trout occupancy. So if you want to go fish for trout, don't go down here in Virginia, go up to Maine. So this is Huck 8. This is Huck 6. And then if we want to go down to Huck 12, this is kind of the catchment size. You can also do that. So you can see when you go finer, you start to see Mount Washington here in New Hampshire pop out. That's our big mountain in the Northeast. It's like 5,000 or 6,000 feet. But you can go even finer than that. Say you want to go into one of these Huck 8s and you want to look at the catchments. So these average about 2 kilometers squared, 2 or 3 kilometers squared. Now we can look at elevation here, and you can see kind of a main stem and then some highlands up here. But I wanted to zoom in so to show you how we use the filters, the cross filters. So now we can pick cross filters for the variables that are in this. So let's say we want to find something about elevation and something about maybe brook trout occupancy. So we're going to select those two variables, and then those get added in, the histograms get added to the filtering. And so these histograms operate just like the first version I showed you. They interact with each other, but now we've also added it so that they interact with the map. And this is where it gets really powerful. So when we first show the histograms, what you see here is blue ones, which is all of the catchments all the way from Virginia to Maine. So that's kind of the background. And then orange is for this one Huck 8 that we've looked at. So you can see in general, the Huck 8 is has slightly higher elevation and has very high probability of occupancy for brook trout. There's not very many low probability locations. So this is obviously a good place for brook trout compared to the whole range. So let's say you wanted to find the high, let's say low elevation. Maybe that's more interesting because it's a little less likely to have high probability of occupancy. So if you wanted to find just the low elevation, now this is interacting with the other histogram and with the map. So in low elevation, there's this distribution in the orange that we're looking at for the catchments of probabilities of occupancy. And as we slide this window going from low elevation to high elevation, you can see how the map is interacting with it and also the probability of occupancy. So you can quickly learn where in this watershed the high elevation locations are. That's not, that's not groundbreaking or anything, but it can be more interesting with other variables. But this is just a good example because it kind of climbs up the hill. But you can also see how elevation and occupancy are related to each other. And you can see in this small example, they're moving together. So there's a positive relationship between occupancy and elevation, like you'd expect. So higher elevations have higher occupancy. So you can do that. We selected elevation, and now we can say where are the very highest probabilities of occupancy within what we selected for elevation. So now we've filtered for both elevation and probability of occupancy. So these are the locations down here in the purple that are still lit up that meet both criteria. So you can imagine this is really nice for the natural resource manager. We don't have to tell them anything except how to use this, and they can make decisions based on these variables on their own. And there's ways to save this setup and kind of export it. If this is an interesting thing to you, there's a user guide here that goes into detail. I think there's a video in there still that shows how to use this in more detail. Okay, so this is at the very smallest scale. But you can see down here that we're at this sort of 10 kilometer scale. So now let's zoom up to the whole region. Maybe you wanted to make decisions based on the whole region. What we're going to look at is the proportion within each HUC 8. What is the proportion of catchments, of these little catchments that get lit up? So we're going to get out of. Whoops, we're going to unselect and zoom out. I'll hit reset and reset. And we're going to zoom way out and switch this to % area filtered. So right now there's no filters, so everything is 100%. Every HUC has 100% of the catchments selected. But say we wanted to look at similar kind of thing that we looked at before, show us the low elevation. So now we're looking across the whole region from Maine to Virginia. Where are the low elevation locations? And you can see that, not a surprise, it's coastal and near the Great Lakes over here. But as you change this, as you move this, you can see very, very easily and sort of teach yourself quickly by making, again, kind of a movie how elevation changes. And if you look down below, you can also see that the probability of occupancy changes dramatically. From now, we're at 600, I'm comparing the two histograms. So we're at 600 meters elevation and 70% occupancy. Now we're down at 200 elevation and we're at 40% occupancy. So this is a nice tool to help people understand how the models work. Elevation is a driver in the occupancy model. And you can see that there's a strong positive relationship between elevation and occupancy. So I really like this because it can help people who don't necessarily understand the models or don't have time or don't want to understand the models. They can understand the direction and magnitude of the relationships between variables. So back to our question, let's find where are the low elevation, high probability of occupancy locations. And you can see basically you're out of luck in the southern region and pretty much up in Maine and parts of Massachusetts here have locations that meet those criteria. So again, this is a nice. I really like this way of interacting with the cross filters because you can, by playing with them together, you can understand relationships between variables, but also having it interact with the map is really handy for people to be able to identify locations. Let's see. let me just show you guys a couple more really quickly. I know there's not much time left. This one is interesting to me anyways. And the idea here is USGS produces tons of hydrographs. And so here's an example of a hydrograph. But people don't always have kind of an immediate connection with that, it's hard to get a feel for what this hydrograph tells us, especially for the general public. So my idea a while ago is to link it to images. So right now this doesn't use cross filters, but it does use D3 and some other fun things to link the images with the graph. This is a really simple way to say, well, what does it look at high flow? So here's one flood, and then we can zoom over here. What's it look like at low flow in the summer? And do these different floods kind of look the same as each other or not? And this, I'm partially showing you this because the EPA, I think on the east side of the country, the EPA got interested in this and actually funded an expansion of this to multiple locations, and to see if we can use artificial intelligence to estimate flow from images as a kind of low-cost way to gauge headwater streams, because a lot of the USGS gauges are not in headwater streams. So that's something we're working on now. This one is I'm calling it the Cumulative Time Series Explorer, and it's one that I'm right in the middle of working on. So I'm going to show the dirty laundry here, and this is what an app looks like when it's not done. But I just wanted to kind of throw this out there because I wanted to hear if there's anything similar that you guys know about. The idea here is to be able to ask, and many people ask this, is this a cold spring or is this a wet spring? So in this case, we're just looking at air temperature, and this is a record from 1942 in Oregon in the Malheur, I think park or range. Christian Torgensen pointed me to this location because it has a long time series and it's near one of their study areas. And what I wanted to be able to do is it can be a little misleading if you are asking questions about whether this is a cold spring or not, because spring might mean different things to different people. So I wanted to be able to look at cumulative temperatures, or whatever time series it is, in this case temperature, and allow people to define the start time and the end time of the the chunk of time that you want to look at. So what this thing does is let you, just like kind of you might have seen on stocks where you can zoom in or out, there's the full time series down here. And if we zoom down into a short section, so say we want to know whether we're in, say, 1953 here, more or less, how does 1953 compare to all the other years? So what this is doing is it's calculating the cumulative temperature in red for the part that we selected. So this is a filter, just like we've been filtering. That's in red, and then it's chunking up all the different years. You can see with these little tiny bars. It's calculating the cumulative temperature for the same time period, essentially the same season. This is more than a season, but the same chunk of time as far as day of year goes for the other years. And it goes from purple from before and yellow to more recent. So you can see that really quickly that 1953 or whatever it is here is slightly colder than the other years, and that the years maybe get yellower as we go on, which suggests there's warming over time. So I'd love to talk to anybody who might be interested in this kind of thing, because this is right in the middle of development. And the idea is that there would be a map over here somewhere that you pick your location and be able to do this kind of analysis. Okay, so that's a quick tour through a bunch of things. And one point I want to make here just at the end is that custom maps like these are all custom maps that we wrote. They require, not me, but they require, like Jeff, excellent developers, but they certainly won't be necessary for lots and lots of applications. But when something like a cross filter interacting with these maps, or something pretty complicated like that, either the picture viewer or the cumulative time series explorer. Those kinds of things do require custom applications. And just for the people that care about this kind of thing, real quick, right here at the end, I just want to tell you really quickly what our tech stack is. It's View for the foundation of the web page, D3 for moving things around, Leaflet for maps, Crossfilter like I showed you, and dimensional charting is a nice way to make easy graphs with cross filters. So it's been really fun making all these things and talking about them and showing them to people. And I hope there's something here that gets you excited about data visualization, or makes you want to make something similar, or maybe is even useful to you. So I'd love to hear what you guys think about all this, and happy to answer any questions that you might have.
Thank you, Ben. That was impressive. I didn't know anything about cross filters. Yeah, that's new to me. I have a question. You were showing us 2 cross filters at a time. Can you use more than 2 variables at a time? You said something about using and.
Yeah, so here, yep. So in this case, we're looking at 2, but you can drop down as many as you want. It gets a little confusing after 3, just because a lot of things to keep track of. But yeah, you can put as many as you want. You can add as many as you want to this mapping system.
I have one question. Someone, let's see. What does he mean by cumulative temperature?
What does he mean? Okay,
yeah.
so we filtered, yeah, and I probably shouldn't have showed this, but I'm excited about it because it's literally working on it this morning and probably this afternoon. But so we have this long time series, right? And we want to be able to look at a part of it. So we filtered down to this, say, 1953. And what we see up here now in the graph is what we filtered. So this little tiny chunk in the gray is the same. The blue here, the blue temperature, you can see it kind of going down and up, is the same as what we see now in the graph. So cumulative, it's like degree days, is an easier way to think about it. So basically we're calculating degree day, we're adding the temperature value over time, adding it up and accumulating it and making it a cumulative temperature. And that's what's in the red line here. The red line is the cumulative temperature of the blue line. So it's just adding it up over time.
So you just add each successive temperature to the previous.
Yep, and just accumulate
set of temperatures.
So that's a nice way to compare among years, because everything starts at 0.
Mm-hmm. Any other questions? I actually have another question. I thought about it. Your PID tag data, what is the source for your data, and is it auto-fed through APIs or not? No. So this is a study we did from 1997 to 2016. So there's nothing updatable. It's all just static data. Oh, okay.
But I'm sure, yeah, there's really cool examples. I think, like you guys were talking about before, of having all that automated. So you could have like a version of this that's real time updated. And that would be pretty cool. Right.
Yeah, the data would need to be QA QC'd, but sure.
Yeah.
This is a great little illustration of how the cross filters work. I like this. Any other questions or feedback? I have a question for Neil. That's why I mentioned your name. Okay, we had a question from the audience. Good. Have you gotten feedback from the council members or others on your products? Are they using the handout?
So I guess first remember, these products were all developed closely with the council members, council staff, as well as that broad user group. We received feedback from those individuals throughout the entire development of the product. Now, the product was just released to the public last Wednesday. I don't have a data set yet, in what is it, just over a week. So,
no, yeah.
So, get back to me in a couple weeks and I could have an answer, but just a week out since it's released, no, we have no information.
You stressed, and a lot of people in our group over time have stressed that audience is key. The audience that you're targeting for a given data visualization, and I guess your audience is somewhat high level. You painted a broad brush, you liked billboards, I like that term. But your audience who would be interested is, I think, a little broader. There are scientists who are interested in the data behind the numbers. And are you able to drill down and find, say, models or?
Yeah, and I alluded to that also, in that's what's coming in 2020. Stay tuned with our program tracker. You're gonna be able to drill into those data sets that have allowed for us to do the roll-ups. Essentially, the roll-ups are what you're seeing in the billboards. I wish I could have taken you guys on a full tour of the Northern Pike tool. Again, allow us to come back and present in the coming months. And that would be a great example of where we have the billboards. And then I teased you with those dashboards, that second one, which really is the numbers. But yeah, give us that opportunity to come back. But that program tracker piece that I highlighted at the bottom of the one particular page is in development right now, and both of those products will be released in 2020. The Northern Pike, like I said, it could be released as soon as December. Probably more than likely it'll be January.
Okay.
So no, I guess going back to the first question though is we're looking forward to seeing the type of responses we get in the coming weeks and months, but it's a little premature right now to be able to judge how successful this, shall we call it, campaign has been, or this marketing of the program accomplishments has been.
Right. All right. So any more questions for Ben or Neil? I thank Ben and Neil very much for presenting a lot of great information and data. And I also thank you all for attending and for your interest